In this video, we'll pick up with our hot dog stand model that we did in the previous video and add a couple of interesting features. So recall that we have customers that arrive and are served by the hot dog vendor, and then they depart. And the interesting component of our model was that we have a time-varying arrival rate. So we have a day that's defined between 9 in the morning and 3 in the afternoon, and we have a different arrival rate in the morning and during the lunch rush and during the afternoon period, and we implemented that with an arrival table. And in this video, what we're going to look at is how we can specify that we have during this lunch rush, we have, instead of one vendor, we have two vendors, but only during the lunch rush because we saw that we had plenty of capacity during the initial period and the final period. And the second thing we'll look at in this video is how to implement something called an arrival table, where we can actually read external data that specifies arrivals to our system, and then we can do experimentation based on those actual arrival times. So here we are with our model, and we have run in interactive mode. And so what we see here is we have arrivals faster than we can process during this lunch rush, which we knew was going to happen when we looked at our data. So what we want to do first is look at how we can have two vendors during this lunch rush period. And in Simio, we do that using an arrival schedule. So I'm going to go back to my data and go to the schedules option, and note that this is a fairly comprehensive feature of Simio, and we're just going to do a very simple implementation of this. And so we're going to start out with a work schedule that's called the standard week, and we go to the second tab for day pattern, and the description here is a standard 8 to 5 work day. Of course, we don't have 8 to 5, so we're just going to change the name to 9 to 3. And then I'll click on the expansion cross here, and now we can specify the value, or the number of units of capacity for a given time period. And so what we want to do is make this 9 a.m. for 2 hours, and so that will be from 9 to 11. We want to have one worker. Then from 11 in the morning, let me get back to 11 in the morning. Oops, I'll just type it in. 11 a.m. for 2 hours, we want to have 2 people. And then from 1 p.m. for 2 hours, we want to go back to 1. And so our work period then for the standard day says from 9 to 11 we want one person, from 11 to 2 from 11 to 1 we want 2 people, and then from 1 to 3 we want one person. So we define this as what we call a standard week. Then I can go back to my model, click on the vendor, and over in the property section where we have capacity type, we're going to change from fixed capacity to a work schedule. And then we see the additional property here of specifying the work schedule, and we want the standard week. And so what we've done is said, instead of using a fixed capacity of 1, we want to use the schedule where we have 1 during the initial period, 2 during the lunch rush, and then 1 during the final period. So when we run in interactive mode here, what we now should hope to see is not a significant increase in the number of customer arrive, or the number of people in the system during the lunch rush, because we have added additional capacity to our vendor resource to accommodate for that. So as we run, we can see now we're entering the lunch rush, and so we did have this a couple of spikes here, but certainly not as high as we had seen previously when we only had a single vendor there. So as this runs, we're going to see that we have a potential problem here at our time 3 p.m. and the problem occurs if we have a customer in the system at time 3 p.m. when our schedule says that the resource is not available, because we have the resource available starting at 9 and going until 3. And so that's what we see right here in our numbering system. So our numbering system is still 1, but there's no one available. And we're going to fix that by going back and just increasing the duration of this last time bucket to say 4 hours, so that we're going to allow this extra time, so that if a customer's in the system at 3 p.m., you're going to continue to serve that person. And so now when we run and I can just run in fast forward mode here, we'll see that in fact we do stop at 6.01. So that final person left immediately. Of course, this is only one run, and so we need to go back to our experiment, and you can see that I still have the results here from our previous run where we only have a single capacity vendor. So let's reset that, and let's run under our new conditions. And now under our new conditions we can see that we've significantly decreased the maximum number in system, as well as, of course, the time in system. And so, as I mentioned earlier when I talked about the use of work schedules is a very comprehensive feature, and perhaps in a later lab we will do a more comprehensive coverage of this feature. But for now, that's all we're going to do with the work schedule. The last thing that we're going to do in this lab is look at one more option for creating entities. And so in this lab alone, we've looked at using an arrival time, and we've looked at using a time-varying arrival rate. The final method we're going to look at involves using external arrival times. And so you can see I have an Excel spreadsheet that just lists a sequence of arrival times. And so these are in hour units, so real numbers corresponding to hours. So this would be 0.07863 hours into the run is when our first arrival occur. 0.01294 is when our second arrival occur. Of course, we could also use this feature specified in terms of Simio date time format, so I could say particular day, particular time if I wanted to, but we're going to start out just using these real numbers because it's fairly simple to do. So I'm going to go back to our model, go to data, and I'm going to create a table. And my data table that I'm going to create, let's just name this arrivals. And we need a single column in this table. And so my single column is going to be a real. And let's call this arrive time. And so I have my Excel model, my Excel spreadsheet here for arrive times. So I'm simply going to bind this table to my external table. So we'll bind that to our arrive times. While Simio finds my sheet. Let's see here. There we go. And I'm going to bind it. Of course it worked. And I'm going to then switch to manual mode and import the values. So these are the values, the arrive time that we imported directly from our Simio model. So now we'll go back to our facility, go to our source, and change our arrival mode from time varying to arrival table. Simio will then say, which table would you like to use? And of course, we specify the arrivals table dot arrive time. So not only do I specify the table, but I specify the column that includes the arrival time. And so now the other thing I'm going to change is get rid of the maximum time and run the model. And so now instead of generating the time varying arrival rate or the in-arrival time, the random in-arrival times, Simio is simply reading the values from that specified table to determine when the arrivals should occur. And with the arrival table, Simio doesn't know or care where the data actually came from. So I have the Excel spreadsheet in this case, and I simply imported the data. This could be data from a time study, so I could have multiple days of actual observations. I could then read those in individually and conduct an experiment where I change the structure of the system somehow using real arrival data. So it's a very interesting feature. One other component of that is we can also add variability to the process. So if I look at my source object, when I have an arrival mode of arrival table, I also have this arrival time deviation and arrival no-show probability. So arrival time deviation will let me specify a potentially random deviation about the arrival time. So for example, if I have random.uniform minus 0.1.1, the arrival time will deviate from the specified times according to a uniform distribution with values negative 0.1 to 0.1. And so those values will be sampled. The value will be sampled and then the deviation will be sampled and the arrival will occur according to that deviation. Similarly, we can also have a no-show probability, so I can specify probability that an individual arrival will just not occur. And so if you think about perhaps a doctor's office, dentist's office, or something like that, where you have fixed arrival times, and then you might have the deviation, and you might also have a no-show probability. So it provides a nice mechanism to do experimentation around that fixed arrival time. Of course, with a hot dog stand, this random arrival deviation might not make as much sense as it would in say, a doctor's office, but I think you get the idea of how you could use the feature. So one final comment for this video, which I'll just show and we won't go through in detail, is that I actually created the data, the external data, using the hot dog model. So let me jump over to the model, or actually this is another version of the same model, and you can see what I did in this model is add an add-on process that uses the write step. And the write step allows you to write data to an external file. And so I write just one row of data, time now. So what happens is I have my file data and my, definitions, file, there it is. And so I have a file called arrivetimes.txt. I have a process called write timestamp. When you execute the process, it simply writes a row to the file. And in my facility, I have an add-on process for the source that happens when an entity is created. So when I run this version of the model, every time an entity is created, and I'm using the time varying arrival rate, I execute that add-on process and it writes a value. And so when I then import that data file into Excel, you can see I get the arrival times. So for this lab, I actually generated the data using a model. I then imported that arrival data into another model. So again, in this lab, I didn't want to go through the details of the write step and how to use it. I just wanted to give a quick overview because I in fact used that feature to generate the data. So in summary, again, in this lab what we looked at was two basic features. One was implement a vendor schedule, or a schedule for our vendor resource. And so we implemented a standard schedule where we specified that we have one worker during the morning period, 2 workers during the lunch rush, and then 1 worker during the afternoon period. And then the second feature we looked at was using an arrival table so that we can specify the arrival times using external data.